Hi, hello, this is Panir. In this video, we are going to see about IR instrumentation and interpretation. Under this heading, we are going to cover the following content that are about IR and IR instrumentation, types of functional groups, finally, a brief about IR interpretation. What is IR? IR is the measurement of the interaction of infrared radiation with sample by absorption of vibrational energy to study and identify chemical substances or functional groups. In one word, IR is used to identify functional group by the absorption of vibrational energy. This is what about IR. The range of IR is 2.5 to 25 micron. In centimeter inverse, we can tell 4000 to 400. Now we are going to see about instrumentation. That instrumentation, there are various parts. I would like to explain first what is the use of the parts. Number one, nichrome wire. There is a IR radiation source. Second one is mirror, which is used to split the IR radiation. Then there is a reference cell and sample cell. And there is a beam chamber, which is again used to split the IR radiation. And there is a grating which is used to improve the IR radiation resolution. And there is a slit which is used to allow only IR range radiation into detector. Finally, the detector used to produce the spectrum of IR. This is what the different parts and its function. Now we'll see that working principle. Nichrome wire will generate IR radiation. When this IR radiation reaches a mirror, mirror is to split the IR radiation. That splitted IR radiation is to go into reference as well sample cell. When it goes into the reference cell, there used to keep KBr, potassium bromide, as a reference. Why KBr? In the sense, KBr used to transmit 100% of IR radiation. There is no absorption of IR radiation by KBr due to KBr high mass and high polarity. That is the only reason we are using KBr as a reference in IR. Then in sample, when the IR radiation enter into the sample cell, that sample need some quality to absorb the IR radiation. What quality it need? In the sense, the sample must have free hydrogen or types of bond, whether it has an inductive effect or not, whether the sample is having resonance or not, what is the mass of the sample, whether it has a hybridization or not. These six different factors are doing major role in the sample to absorb the IR radiation. When the absorption takes place, when IR radiation energy and these factors energy matches, there will be a absorption. When absorption takes place, there will be a vibration. That vibration again two type, that is stretching and bending. If it is a stretching, then there are two types: symmetric stretching and asymmetric stretching. If it is a bending, there are four different type of bending, that is rocking, scissoring, wagging, twisting. Okay. After the absorption, what will happen? In the sense, the IR radiation passed this sample cell as a reduced IR radiation. This reduced IR radiation used to reach the beam chamber. Again, this beam chamber used to split the reduced IR radiation into mirror. This splitter IR radiation, when reaches the mirror, again mirror is to send this reduced IR radiation into grating. The grating is to improve the resolution of the reduced IR radiation. Through the slit, only the reduced IR range is to go and reaches the detector. After reaching it to the detector is to produce the IR spectrum. This is what happening in the IR instrumentation. Next, IR interpretation. To interpret IR spectrum, you need some of the basic knowledge. Number one, you need to know about how the functional groups are looking. To understand this, I simplified the or classified the functional groups in five different way. One is number one, alkane, alkene, alkyne, and arene. Number two, amine, nitrile, nitro compound, imine. Here, these all the amine, nitrile, nitro compound, imine. These all the compounds are having nitrogen. Then alcohol and derivatives. Alcohol it has OH, ether. In the place of hydrogen, again one more alkyl group. Then thiol. In the place of O, there is sulfur. So this is third one. Fourth category, carbonyl compound, that is ketone and aldehyde. Finally, carboxylic acid and its derivatives. Carboxylic acid, already you know it, RCOOH. Its derivatives are ester, amide, anhydride, acetyl halide. Four derivatives are there in carboxylic acid. At least you must know about these functional groups, and you have to keep these functional groups in your mind before interpret the IR spectrum. Next, number one, need to keep the functional groups in your mind. Second one, if I am giving any structure of the compound, you are in the position to dismantle the functional group. Dismantle the functional group in the structure. You have to develop your knowledge such a way. If any structure given to you, you have to dismantle the structure based on its functional group. Here, I gave paracetamol. In the paracetamol, there are seven functional groups are there. Out of that seven functional group, I have mentioned five functional groups are mandatory or core functional group to confirm the paracetamol structure. That are number one is OH, number 2 NH, number 3 aromatic CH, number 4 CO, carbonyl functional group, at the last aliphatic CH. At least these three, at least these five functional group peaks has to be there in the spectrum. Then only we can confirm the structure. This is number two. What you have to keep it in your mind. Number one, functional group. Number two, you are in the position to dismantle the structure based on its functional group. Next, you need an idea about what factor is present in the structure. If these factors are present in the structure, what will happen? I said that six factors. Number one is free hydrogen. For that example is acetic acid and methanamine. You can see that there are free hydrogen in acetic acid and methanamine. Second one is number of bond, whether the structure or the sample is having triple bond, double bond or single bond. Third one is inductive effect, whether the structure is having a high electron activity atom, due to that it has an inductive effect or not. And resonance, whether it has a resonance compared to penta 1,3 diene, benzene is having more resonance. And mass, when compared to methanol, when compared to methylamine, methanol is having more molecular weight. Why? Because oxygen atomic weight is higher than the nitrogen. Finally, whether the sample is having hybridization. Hybridization in the sense, what kind of hybridization? It is sp or sp2 or sp3. So these are all the factors and its example. So if these factors are there in the sample, then only sample can absorb the IR radiation. Okay, if the factor is present in the sample, how the sample used to react? For example, if the sample is having free hydrogen, for example, we seen acetic acid and methanamine, what will happen? When these groups are present in the sample is going to absorb the IR radiation. If absorb the IR radiation, what will happen in the wave number? Wave number will get increase. Such a way, if it's a triple bond, wave number will increase when compared to double bond. Double bond wave number is going to increase compared to single bond. If the structure is having inductive effect, that wave number is high when compared to less inductive effect or no inductive effect. If the structure or the sample is having resonance, take benzene. When compared to penta 1,3 diene, benzene resonance is high, so that benzene wave number is high. When compared to methylamine, methanol is having higher molecular weight or higher mass due to oxygen, so that methanol wave number is high when compared to methylamine. Finally, hybridization. Hybridization, sp hybridization, sp2 hybridization and sp3 hybridization. In such a way, single bond is having less wave number when compared to sp2. sp2 hybridization is less when compared to sp3. This is the order. And what is the influence factor is doing in the IR absorption. So these factors, how the factors are functioning, this knowledge has to be there if you need to interpret IR spectrum. First one, you need an idea about functional group. Second one, you should dismantle the structure based on the functional group. Number three, you must know about the what are all the factors are involving for the absorption of IR radiation. What next? This is very important. You must know what happening in the IR spectrum. There are three possibilities in IR spectrum. One is flat line, small peak and large peak. Why flat line? When there is absorption, when there is IR radiation passes via the sample, sample is having factors and factor is having energy, IR radiation is having energy. When these two energy meets, there is a absorption. There is a absorption. When the absorption takes place, there is no intensity. There is no intensity. Then entire IR radiation passed without absorption. In such a case, you will get flat line. Second one, why small? The same thing. When energy matches, there is absorption. The absorption intensity is low, then you will get small peak. If the absorption intensity is so high, then you will get sharp and long peak. This is what the peak indicates in the IR spectrum. Why flat? Why small? Why large? And next, zones. Free hydrogen zone, triple bond zone, double bond zone, and fingerprint zone. You can keep in your mind IR spectrum is having four different zones. Okay, free hydrogen already you know is one of the factor. Which are all the things you used to tell free hydrogen? Which are all the functional groups are having free hydrogen? Hydroxy, NH amino and aliphatic CH, aromatic CH. These are all having free hydrogen. When this free hydrogen present in the sample, then you can expect the peak from 3500 to 2500. If any compound is having triple bond, for example alkyne, nitrile, then you can expect the peak from 2500 to 2000. If any compound is having double bond, for example alkene, carbonyl compounds, carboxylic acid is having CO, carbonyl compound is having CO, those CO where we can expect in the sense 2000 to 1500. In this range you can expect. Finally, fingerprint zone. This fingerprint zone is very important to identify what kind of halogen is present in the sample, as well the orientation. What do you mean by orientation? When there is a single substitution or mono substitution present in the aromatic ring, then there is a orientation for incoming group. That orientation might be a ortho, meta, para. Such a case, to distinguish ortho, meta, para, this IR spectrum is very useful, and again fingerprint zone is very useful. There you can identify which kind of orientation is present in the sample. This is the four different zone which you have to keep it in your mind before interpreting any of the IR spectra. What are all that? Free hydrogen zone, triple bond zone, double bond zone, and fourth one fingerprint zone. What next? This is free hydrogen zone. Already I said that if it is free hydrogen, which are all the functional groups are having free hydrogen? Hydroxy and amino. Okay. So here hydroxy range 3600 to 3200. If benzene is having OH in direct attachment, we used to call phenol. If phenol is present in the sample, then you have to get sharp peak at 3500 centimeter inverse. and any amino group present, then there is a range 3500 to 2500. Now we will ask a question that alcohol also is having hydroxy group, carboxylic acid also is having hydroxy group. How I can differentiate? Easily you can differentiate with, if alcohol is present, you have to get OH peak. Carboxylic group is there, you have to get OH peak. But there is no carbonyl group present in the alcohol, so that you have to get two peaks for carboxylic acid and its derivatives. That carbonyl peak is missing in alcohol. In that way, you can differentiate easily alcohol as well carboxylic acid. If any triple bond is present in the compound, then it used to come 3300 centimeter inverse. If double and single bond, CH stress, where you can expect ethene, benzene CH, and again anhydrides, acetate, carbonyl compound. See here that anhydride, acetate, carbonyl compound, these all are having CH. What CH? This CH is to call free hydrogen. That hydrogen is to call free hydrogen. That free hydrogen, where you can expect the peak in the range of 2820 to 2720. There you have to get the peak. If it is a alkane CH, that H also free hydrogen. For that you have to get the peak at 2960 to 2850. Finally, presence of carbonyl group. If the presence of carbonyl group in the compound, you have to get the peak from 1600 to 1800 centimeter inverse. With presence of halogen, you can expect the peaks where in the fingerprint region. If it is fluorine, 1400 to 1000. If it is chlorine, 785. Bromine and iodine, you can expect nearby 660 centimeter inverse. So this is one example. This is a structure. If I am giving you a structure like this, first duty, you have to dismantle the structure based on the functional group. In this structure, what and all is available? One is amide functional group, second one is carboxylic functional group, third one is aromatic ring. That aromatic ring, CH. That CH is what? Arene, or it's double bond CH. Here there is a free hydrogen. In amide, NH is having free hydrogen. In carboxylic acid, OH is having free hydrogen. And again, here there are two carbonyl group is there. In such a case, one is nearby NH, one is nearby OH. So OH is having oxygen, NH is having N. Compared to nitrogen, oxygen molecular weight is high, so that hydroxy carbonyl group is having higher wave number compared to this NH carbonyl group. So you can see the spectrum. This is for OH, this is for NH, this is for what CH? Aromatic CH. CH peak and carboxylic CO peak, amide CO peak. These are all the five main function group which is present in the structure. For this five main function group, you need to get the peak in the IR spectrum. If these peaks are available in the IR spectrum, then you can confirm that this spectrum and its values are corresponds to the structure. This one example. Second one, if I am giving structure like this, what is your duty? You have to identify what are all the function group present in the structure. Any structure given to you, you have to tell very easily what are all the function group is present in the structure. You have to dismantle the structure based on the functional group. See that if you are taking here, it has number 1, number 2, number 3, number 4, 4 functional group in it. Here number 1, number 2, number 3, number 4, number 5, 5 functional group in it. Such a way, you have to first dismantle the structure based on the functional group. Then you have to think of what are all the factors are there. Then think of what are all the factors. The factors lies with which zone. You have to club these three. Number 1, structure dismantling based on the function group. Number 2, what is the factor involved in the structure. Number 3, that factor lies with which zone. It is a free hydrogen zone or a triple bond zone or double bond zone. Finally, whether it is in fingerprint zone. It's very simple. Next, if I am giving you any spectrum, you can easily interpret it if you know the concept. This is the spectrum. You can easily tell that what are all the possibilities of functional group based on the spectrum. So there is a OH peak, there is a NH peak, there is a aromatic CH structure, aliphatic CH structure, as well as alkyne triple bond stretch, and again a carbonyl group stretch. Can easily tell that if you know the concept. See here, OH stretch, NH stretch, aromatic CH, alkyne means a triple bond stretch, carbonyl stretch, ether stretch, halogen peaks also available. So what you need to know to interpret the IR spectrum in the sense, you need to know what are the functional group, how the functional group used to look, and second one, how I can dismantle the structure based on the functional group, then what are the factors involving the absorption of IR radiation, finally where this factor lies in the zone, IR spectrum zone. If you know this all four, then interpreting IR spectrum is very easy. So you have to concentrate on functional group first. Then one by one you have to concentrate. Then any IR spectrum you can easily interpret. They are giving spectrum to structure is also okay. Structure to spectrum also okay. You can easily tell that where you can get the peaks, and the peaks for what. So that's all about IR instrumentation and how to interpret the IR spectrum. I hope this video is really very useful those who wants to interpret the IR spectrum. So finally, thanks for listening as well. Thanks for watching this video. If you like this video, subscribe my channel as well. Share this video those who really in need to know how to interpret IR spectrum. Once again, thanks for watching.